Starting up the stream and just putting this in the screen so everybody knows what to expect here. Not necessarily going to be chatting or talking too much because I need to actually focus on my studies, of course. Planning to do 2 Pomodoros today of 50 minutes. So about 2 hours of study time. Maybe I'll do some network policies after that, but we'll see how the next 2 hours are going to go.
Ingresses or securing ingresses in the CKS. We will talk about node metadata when it comes to cloud platforms, what it is. Next, we will actually access sensitive node metadata, and finally we will restrict it using network policies. Cloud platform node metadata, what is this? If we spin up virtual machines in a cloud provider of our choice, Google Cloud, AWS, Azure, then there's usually a metadata server which we don't manage, which the cloud provider manages for us, but the virtual machines are able to connect with this metadata server and get some information about the environment, about the service account they use, and there can be credentials and sensitive information to spin up their services. So Metadata Service API is by default reachable from virtual machines. It can contain cloud credentials for VMs and nodes, so sensitive information, are able to connect with this metadata server and use, and they can their services. Machines. This can mean, for example, data to provision the kubelet credentials on a worker node. So limiting the permissions for instance credentials, this is kind of outside of the scope of Kubernetes. This means ensuring that the cloud instance account, so the account which the instance can use to connect to the metadata server or to other APIs, that it only has the necessary permissions, right? And each cloud provider has a set of recommendations for it. Some maybe have good default settings. For some, you might have to adjust it. But this is not in the hands of Kubernetes, and this goes too much into cloud management. But it's just something that you should be aware of. Restricting access using network policies. Well, if we have now a cloud account, like in Google Cloud, like we actually have, and we build our own Kubernetes cluster, as we see here, then we might have a worker node virtual machine, right? As we do. We have one master and one worker. And then in that worker, we have some pods running, which are actually run as processes, as Docker containers and processes internally on the operating system. And then by default, these pods and containers can also contact the metadata server, right? So it's not even a matter that someone has to break out of a container and then from the node contact the metadata server. Like even before this, usually with the default configuration, it's possible for pods to contact the metadata server and maybe to query sensitive information. So what we can do with network policies is to allow certain pods to access these and to deny certain pods to access these. We will now access GCP Google Cloud metadata from an instance and from a pod. For this, I'm on my master node. The cluster is ready as always. And I'm actually on a Google Cloud page called Storing and Retrieving Instance Metadata. The link is in the resources section of this video. And this, again, accessing the metadata server. The metadata server exists for most cloud providers, but it's different. It's cloud provider dependent how to access it, right? It might be just a IP, it might be a domain name that you have to query. So it's dependent. But here also you see caution. A process can query the metadata URL a process that can query the metadata URL has access to all values in the metadata server. So there are some examples. So we can simply search for curl, and I saw something about querying disks exactly. So we simply copy the comment, execute it, and we see we actually got a response, and we get some information back. So it's not really about the information that we get back right now. It's simply the fact that we can connect to the metadata server. Now we see that we can do it from the instance, from the master instance. It will work the same from the worker instance. It's simply 2 virtual machines. But now the thing is, it also works from pods. So we create a simple pod called Nginx, image Nginx. It already exists. Great. I simply exec into it, get a shell, and then run the same command, and we see it works. Okay, so by default we see now that pods can access the GCP metadata server.
I never knew about that, so that's interesting. So how does this work in Azure metadata server? Azure Instance Metadata Service provides information about currently running virtual machine instances. You can use it to manage and configure your virtual machines. Interesting. That is really interesting. So you must bypass proxies. I didn't know you could do that, but that does mean security authentication is only accessible from within a running virtual machine instance on a non-routable IP address. VMs can only interact with their own metadata and functionality. I mean, of course you don't want that open, but does that really contain important information? Like, I can hardly imagine they would have credentials in there or passwords, secrets. It would give this location of the secret and password. Don't think you could actually get hackable information from there, but yeah, it's still good to know. Learned something new today.
Just like that. We will now only allow certain pods having a certain label to access the endpoint. For this, we will create 2 network policies, which are actually in our GitHub repository. The link is in the resources of this video. I mean, we have already a big section about network policies, so we don't go very much into detail here. And we simply create the 2 existing network policies and have a look at them. The first one we want to have a look at is the deny one. So np cloud metadata deny. And here we see that we have a pod selector for everything. So not just specific pods. This will be for all pods in the namespace default. It's about outgoing traffic. And we have one outgoing traffic rule, which means we allow outgoing traffic to all IP addresses except the one of the metadata server. Okay, and that IP address, we can see if we ping that one, that's the IP address of the metadata Google internal server. Okay, copy the network policy and create it. I call the file deny.yaml. There we go, it's already here. And I will create it. There we go. We exec back into our Nginx pod and we try to run curl again and it doesn't work. Okay. This might be something that's a good procedure to do to deny pods to access the metadata server. Now we go ahead and look at the second one, np cloud metadata allow. Here we have a pod selector for role metadata accessor. And these metadata accessor, we additionally allow egress true IP block and then the IP of the metadata server. So this second one, if you would only create this one alone, then these pods would only have access to this IP address. Okay, but if you create it in conjunction together with the deny one, then pods will get this rule, so they can connect to everything except this one, plus the other rule that they can connect to this one. Okay, might be a bit confusing. Maybe pause the video and look at both, and just imagine that if the deny network policy and the allow network policy would be merged, then the first rule would be invalidated by the second rule, kind of. So go ahead, copy the allow network policy. I call it allow.yaml.
Yeah, it's really good that he's emphasizing this, because this was really confusing in the beginning when I was learning these policies. But basically all of the policies in the namespace get merged into one, and then everything gets added, and that's the final policy.
And create it. Great. Now if we have a look at the pods and their labels, then we see right now it has the label run nginx, and we would like to give it the label row metadata accessor to test. So what we can do is k-label pod, and we say row metadata accessor, k-label pod, the name is nginx. There we go. We check labels again, and now our nginx pod has the label row metadata accessor. Okay, we exec back into the pod, and we can see, yes, we can curl the metadata service. And to verify that it actually works, I'm gonna remove the label again. So we see here in my pod, I have the label row metadata accessor. I will remove it again, exec back into the pod, try to execute it again, and it doesn't work. Okay. So yeah, play around with this a little bit. Using this, we were able to default deny for all pods the access to the metadata endpoint, and then simply allow it for certain pods having a certain label. And just a quick recap to end this section. We talked about cloud metadata servers. We talked about that they're different for every cloud provider, how to access them. Usually it's possible to access them from every instance, and usually instances they access which people use.
Okay, let's do a killer quota scenario. But that was, yeah, rather easy subject matter. Metadata, network policy, metadata protection. Oh, I even have already solved this one because I've been practicing network policies so much. But let me see, we can if I can solve this one on the cuff, off the cuff. We assume there's a metadata, yeah. Okay. Create a network policy named metadata server in namespace default, which restricts all egress traffic to that IP. So it should allow all egress traffic except to that IP. So I will go to the Kubernetes docs, concepts, and networking, network policies. And for these exams, it's really important that you learn how to navigate the docs efficiently. I've even heard people say that the search doesn't work sometimes. So that is a real problem. So it's good to also know your way around the sidebar here, so you don't rely on search. So vim np.yaml, insert this example that I grabbed from the docs. Let's go through it one by one. Create a network policy named metadata server. in namespace default, which restricts all egress traffic to the IP. So we're not going to be concerned with ingress. And here's this example IP block cider accept. So I'm going to paste that there. Then I can delete all of the ingress here. So I'm saying that traffic is allowed to the internet 0, 0, 0, 0. So this means traffic to the internet except for 111.111/32. And the namespace was default. The pod selector will be all pods. So this should be it. Let's apply that one. Network policy created. And then let's see, NCV 111.53. And it succeeded. So I probably have it the other way around, the wrong way around. Oh yeah, here we go. I forgot. The network policy should only affect pods with label trust is nope. So we actually have to do a selector here. Pod selector, match labels. Forgot about that one. So pod selector, match labels, trust is nope. Trust, nope. Here we go. Let's apply it again. Now, get pods show labels. There are 2 pods here. Trust is nope. And yeah, no trust and trust. So let's go into the exec IT trust 0 bash. Or I can just execute the command. I don't have to be interactive. NCV 111.153. So from this pod it's open. And then now if I go to the no trust 0, the command doesn't work because I'm selecting that pod with the trust is nope, so it won't work. So the scenario should solve now. Check it. Yep, validation successful. All right, that was easy. Okay, on to the next module then.
CKS benchmarks.
Ooh, this is going to be fun. This is going to be completely new to me. I've never done this before.
Use CKS benchmarks to review security configuration. I will first give you a little introduction, a little overview about what CKS benchmarks are. Then we will jump right into a hands-on session, CKS benchmarks in action, and later on we will use kube-bench to investigate our cluster and to apply security recommendations. CKS benchmarks. So CKS is the Center for Internet Security. And they provide best practices for security configuration of target systems, and they cover, as of now, more than 14 different technology groups, which means not just Kubernetes, okay? They have recommendations for different software products. And to cite, CKS Benchmarks is developed through a unique consensus-based process comprised of cybersecurity professionals and subject matter experts around the world. Well, if that doesn't make you feel more secure, then I don't know what will. Okay, CKS Benchmarks. So CKS Benchmarks, now just Kubernetes, because that's interesting for us. They provide default Kubernetes security rules. We, as administrators, let's say we administrate our own cluster, we can then just use these rules and apply them. Like if we have a cluster, we set it up with Rancher or we set it up with kube-ADM, we can use these rules and apply them. And then we have already a good security base, right? And if you want to adjust this, then you can do it as well. Like if you're a big company and like for example, Google Cloud and AWS, they do this for their managed Kubernetes solutions. They use the CKS benchmarks as a base, they customize them, and then they use and apply them. Google does it a bit longer already, and they provide online a list, so it's like transparent which rules they take, which rules they maybe define more strict to be, and which rules they define less strict to be, right? And then it's really transparent from security, because security is best when it's transparent, so I like this. Yeah, and then you can see what rules are applied. So if you are a company which is pretty large enough and you want to customize the CKS benchmarks, then you can do this as well before you apply them. So that's the general idea of CKS benchmarks. Okay, in this hands-on session, we will actually download and investigate the Kubernetes benchmarks PDF. Okay, so for this, you have to head to your browser and search, really difficult, CKS benchmarks Kubernetes. And then you should see the website, cksecurity.org. You click on Kubernetes benchmarks and download latest CKS benchmarks. You can see for me right now, it's version 1.6.0. Just download the latest version for you. And yes, it is free, but just pause the video now, fill in the information, click the button, wait for the email, and then you can download the PDF. Pause the video, do it now. There you go. You should have your PDF open. You see I have the PDF open. I'm using version 1.6.0. And what should we do in this hands-on session? Check Kubernetes version of your document. What does this mean? Okay, because it was a bit confusing, because the numbers doesn't have anything to do with the number of the Kubernetes cluster, a Kubernetes version that this is applied to, okay? So we scroll down a little bit. Okay, at first we see the content of the document, and the content is structured. We see one are the control plane components, master node, for example, and if we scroll down to section 2, we see section 2 is about etcd, and then section 4 is about worker nodes, right? So that's how it's structured, and then there are like various rules for the various components of Kubernetes. And if we scroll further down, there should be an overview section. And in the overview section, you see this document is made for Kubernetes versions 1.16 and 1.18. We right now work with Kubernetes 1.19, but yeah, I mean, it doesn't matter. Just use, if you work with a Kubernetes version which is above, or like 1 or 2 versions above, not that much should have changed, okay? And what's also important is that these rules are applied by the default configuration of kube-ADM. So wherever kube-ADM puts its configuration files, this document uses this already. And this is great, because the CKS, the clusters that you use in the CKS certification are all configured using kube-ADM. Okay, and we also use kube-ADM in this course. So that's all perfect. Okay. Now, we just look at 2 example rules, okay? So in my document, it's page 16, rule 111. It might be on a different page for you, but the rule number should be the same. So I go to page 16, it's actually 17 for me. Okay, let's just have a look at one example rule, okay? Just that you are a bit that you get a bit used to how the documents are structured. So we are at master node configuration, and 1.1.1. Ensure that the API server pod specification file permissions are set to 644 or more restrictive. Okay, and then you simply have a description, what it is. Okay, so we have to check some file permissions. And then you have an audit, so you can actually run this command to check what the file permissions are, and then you check if it's less or more restrictive. Okay, and if it's not like that, then you see the command that you can execute to fix it. Okay, so you have a command to execute to check it, and you have a command to execute to fix it. It's really simple, okay? Let's have a look at another example as well.
Yeah, okay, so it's just a set of best practices, and I work mostly with Azure Kubernetes Service, and they have this amazing CKS best practices guide. And like in general, you don't even have access to this kind of stuff on a managed Kubernetes cluster like AKS, so you won't be able to even do this kind of auditing. But even then, the AKS offering has these cluster operator best practices, which is just amazing. It has so much good information, and you can just go through it for your organization and do all of the steps and make sure that you comply. And even the Microsoft Defender will also detect this. So it will actually detect whether you are conforming to some of these best practices. It's actually really good. But this kind of stuff on managed Kubernetes, you are not even able to adjust. And I'm fairly sure you can't even do it on Talos either, because you can't even access the node itself. You can't SSH into Talos nodes. You can only use the Talos API.
Well, for me, it's on page 208 for the worker node, rule 4.2.10. So page 208, rule 4.2.10. Ensure that the TLS cert file and TLS private file arguments are set as appropriate. Okay. And then for auditing, we do a PS, so we look at the process and we look with which parameters the process is run. Then we have a recommendation, and then in the recommendation it says where we can change it. We see in this config file we can change it, what we should do, and then we have to restart the service and do it like this. Okay. Feel free to check a few rules out. Not at all do you have to remember any of the rules. You don't have to apply these rules. You don't even have to look at the PDF document in the real CKS certification, right? But you should just be comfortable with the structure, and you should know how to apply a rule. You know, how to maybe fix it. Like you might be faced with a unsecure cluster. You will be provided with some rules, and then you have to change and fix the cluster.
Yeah. So you have to know Linux.
In the whole PDF, you saw it was always structured, right? There was always a comment how to check it, and then an instruction how to fix it. This could also be automated, right? This sounds like we don't have to even use a PDF document. It sounds like this could be something that a program could do as well for us. And yes, that's right. We will do this in the next section.
Here we go, kube-bench. So that's what I was hoping it would be.
We will now use kube-bench, run it on the master node, and apply or check one rule and maybe fix it if it's not properly correctly configured right now. What will we do? Okay, we need to run kube-bench. Okay, for this, just search kube-bench GitHub. It should be the Aqua Security kube-bench repository, and in there, in the README, you see various methods of installing it, of running it. But look at running inside a container, okay? Not installing from a container, look at running inside a container. And there you see a very simple Docker command that you can run. Copy that command, head to your master node.
Okay, let's check it out. Kube-bench. I think I might even have that already, kube-bench. Pretty cool. Okay, so they've changed it a little bit here. There are multiple ways to run kube-bench inside a pod. Well, I can run it as a job. That's nice. Okay, so this is the job. Yeah, we'll try to mount a bunch of things. I don't think my Talos cluster will even allow this, but it will be fun to test. So let's see. I'm gonna go to my Rancher desktop cluster and see what's gonna happen if I run this. Let's see. Make their bench. Kube-bench. And then v job.yaml. Paste that. And okay, so the container is creating. It's pulling the image. Let's see. Okay, so that works. That's pretty cool. Ten checks fail. Cool. So there it runs as a job. And let's go to the head. There we go. Run the below command based on the file system on each worker node. Oh yeah. Pretty interesting. So it just works out of the box like that for my Rancher desktop. After this, I'm gonna try it out on Talos, see what happens.
And here you see you can actually pass a parameter to the container, and this is like master or node, right? So if you're on the master, you want to check your master node, you should pass master. If you want to check your worker node, you should pass node. Type your version, 1.19 I'll do, and just run the command, okay? You might, I mean, in the real world, you might want to install it. Like, you don't have to do this. You don't have to install kube-bench in the CKS certification. You will either be provided with it, or you will just be provided with the rules. So we run it, and we see a summary down here. 43 checks passed, 12 failed, 10 warnings. Okay, 12 failed. Let's have a look. Scroll up a little bit, and here we see a nice colorful overview, and we see one failed rule is 1.1.12. Okay, you could now also check in your let's actually do it. Let's check the rule 1.1.12 in the PDF document. That's the one. Ensure that the etcd data directory ownership is set to etcd. Doesn't seem like it is. Okay, so auditing, we can have a look. We can run that comment. And there we see right now it is at root, at least for me and that version that I'm using right now. What can we do to fix it? Let's have a look. Recommendation. Okay, I'm gonna run this comment. Invalid user, right? Let's simply add for testing etcd user.
Oh, bad idea. You don't want to just add a user, and if it's expecting to run as root, then I wouldn't do this.
Okay, this seems to work. I'm gonna run the check command again, and it is etcd. And now we can run the Docker command again. So we run kube-bench again. And we see that 44 checks passed. This looks better. We scroll up and we can see that 1.1.12, the rule that we just checked, passed now. Okay. Yeah, maybe you should be comfortable with kubeadm like this. Maybe just pick another rule. Maybe also log into your worker node and run the command then not with master here, but with node. And maybe fix the rule there as well on the kubelet, for example. Okay. Well, yeah, this shows you what kube-bench does. It can check the rules automatically for you. And based on this, I don't know, you could, for example, implement this in your continuous integration system or just send it to someone who should work and fix on the security issues. And to finish this session, just some remarks. I would like to shortly show you the GCP CKS benchmark. So we can simply go to a browser and type in gcloud CKS benchmarks. And we see a page from Google, actually, cloud.google.com CKS benchmarks. And on that page, they explain a little bit. And if we scroll down, then we actually see the CKS benchmarks and the level, and if they passed or if they failed, you know. And yeah, and there you see what they actually apply in their GKE as well, like the default values for their GKE cluster. Okay, so this is like really interesting, really transparent. AWS followed as well. Probably, I don't know about Asia or others, but they will probably follow as well.
Let's find that out. AKS sys benchmark. Here we go. Yep, this is the entire one, the entire sys benchmark for AKS, so they also have it. Pretty cool.
If you are more interested, there's a nice talk by Martin White, Consistent Security Controls for CKS Benchmarks, which explains it a lot better. The link is posted in the resources section. There's also a tool Docker Bench if you're interested in it, which checks your Docker configuration. I mean, we will later touch on this as well, because your Kubernetes cluster is only secure if your container runtime is secure itself. We will work on container level a bit more later. So Docker Bench might also be interesting. Maybe not too interesting for the CKS certification. Then it's more interesting to use kube-bench. Well, and that's the end. We learned what CKS benchmarks are. We learned how to use them with kube-bench, like to check. And we learned then, based on the CKS benchmark recommendation, to manually check and also to apply and fix. And that's important for the certification to know.
Okay. So, CKS course environment. Let's see. Well, it's probably just kube-bench, right? Scenarios. CIS. Bench. Yeah, it's just this one. CIS benchmarks, fixed control plane. So he said you don't have to actually be running kube-bench, apparently, for the certification. You will just be provided with some rules. Or maybe it does. Use kube-bench to ensure status pass. Which kube-bench? Yeah, it's already installed. So kube-bench. What if I just do kube-bench? Okay, then it will just show me everything. Kube-bench, and pipe that to Vim. And 1.2.20. Here, fail. Ensure the profiling argument is set to false. Edit the API server pod specification file in etc Kubernetes. Okay. So profiling equals false. Vim profiling. Okay. So I'm gonna do that again, but now I'm just gonna open tmux and do the kube-bench, pipe that to Vim again, open a new window in the meantime, 1.2.20. Here's the profiling equals false. Yep. Here. So there's nothing about profiling here. So then we just go down and add profiling equals false. Now that should be fixed. Let's run the kube-bench again. kubectl could not connect to the Kubernetes server. Maybe it was restarting that pod after I changed the manifest. So 1.2.20. And now it's passing. So that worked. So I'm going like it's gonna pass now. Yeah, validation successful, but just to make sure that I fully understand what is going on here, because I was going a little bit quickly here. 1.2.20. So I'm editing the actual manifest of the API server. I set a parameter there, and if I then do k-get pods-a, do I see the API server here? Here, API server. The API server has been restarted 50 seconds ago, and that would correspond with the change I just made. That's interesting. This thing has been running for 28 days apparently. So this killer coda in the backend probably has a bunch of pods running, and then people connect to them, and then they get restarted after they are finished with the scenario. I think that's what it means. I assume this runs in a Kubernetes cluster. Well, anyway, scenario solved. Let's just check out the results. Oh, they actually did run targets master. I just did kube-bench. I only added this profiling one, and it fixed it. Okay, well, as long as it's fixed. Okay, how much is left on my Pomodoro? Oh, 8 minutes. Well, before I start the next session, maybe I do a few questions here from the chat. Amisha, just wanted to thank you for the content. You appeared exactly the right time for me. Well, thank you, Oliver. That's nice to hear. If you have free time, can you post a separate video how to set up DevOps related tools for more productivity in Mac? Well, that's a very broad question. DevOps related tools. I have this 1.5 hour long video about the tools I use. And yeah, if you want to learn how to set them up, I recommend you take a look at my Skool community. There you can ask me questions directly and I can help you with setting them up. Thanks for the content. Right now I'm getting ready for the CKA exam. So happy you can keep me company. Yeah, that's nice. I'm happy that we can study together. Did you do the CKAD certification? No, I don't have that one yet. I have the CKA. I did that, that's almost 2 years ago now. I did the CKA and then started working with Kubernetes every day. And now I'm doing the CKS. And I plan when I get the CKS, that's when I'll do the CKAD exam. Because I've heard that if you have the CKA, then the CKAD is a piece of cake, or it's a lot easier. So I'll just get that to get the full trio of CKA, CKAD, and CKS. But first, I need to get the CKS. I wonder what the next topic is going to be.
Verify platform binaries.
Oh, there's our answer. Verify platform binaries. I have about 6 minutes left of my Pomodoro, so this seems to be about 6 minutes. So I'll just start with this and then take a break, and I'll be...
We will shortly talk about hashes. Then we will download and verify some Kubernetes binaries. And finally, we do the same from a Kubernetes binary running inside a container. Well, if we have a file and we want to validate it, we want to check that it's actually the file from the original source, what we can do is we can create some kind of a fingerprint of that file, right? And a fingerprint of a file would then be called a hash. There are different algorithms like SHA or MD5. You probably have heard about these. These are one-way algorithms. So it means from a file, you can calculate the hash, but from a hash, you can't calculate the file back. Okay, so it's kind of a compression algorithm and a lossful compression algorithm. And yeah, so what we can do to verify platform binaries, which we'll do on the example of Kubernetes, is to check the hash value, which is provided from the trusted original source, with the hash value that we create of the file. We will now download a Kubernetes release from GitHub and then verify the downloaded files. What you should do is you should head to your master node. You should do kubectl get nodes, and then you should check the Kubernetes version that you are running. I'm using 1.19.1. You might use a later version depending on which version we have in the course install scripts right now. So remember that version and then head to github.com Kubernetes. Okay, so on there you should see releases, or you can see here the tags. And if you click on tags, what you can do is simply open any tag release, and then on top you can simply replace it. You see what I do here. I replace it with 1.19.1, and there I go. This is my release version. And then down here we see additional binary downloads are linked in the changelog. So click on there. Okay, here we see I have the client binaries, which are, for example, the kubelet, and then we have the server binaries, and we would like to download the server binaries. Okay, so here we see the server binary file, AMD64 server Linux, and here we actually see already a SHA-512 hash, which we would compare after downloading the file. So copy the link, head to your master node, download it. There we go. Okay, downloaded the file, we have it here. Now what can we do to compare the hash value, right? We saw it's hash SHA-512, and there should be by default SHA-512 some comment.
Let's see, do I have that? SHA-512 sum. Okay, so I have that.
And on every Linux machine, so we can just call it, pass the file name, and there we go. We see the generated hash. What can we do now to compare these hashes? Well, we can have a short look with our eyes and say, right now, I checked the beginning, I checked the end, yes, it looks fine. But we can also do it a bit more thoroughly. So what I usually do is I pass the output in a new file, compare, head into the new file, and let me remove me for a second. And here on top right, I'll just edit. So I only want to have the hash in that file, right? So I remove the rest of it.
Oh man, $, $. Then you delete until the end of the line.
And then I head to github.com, to the trusted source, and copy that hash, paste it in, and yes, it looks very similar, it looks fine. But what we can also do is we simply output the compare file. There we see both lines, and then we pipe it into unique, and then it only displays unique lines, and then we see, yes, it only displays one, which means these two are unique. So what we did right now is we downloaded.
Yeah, okay, I understand this.
Now it gets really interesting, because now we want to compare the API server binary running inside our container with the one that we downloaded. For this, we are on our master node control plane, and we downloaded the Kubernetes server.
Well, it's time for my break, so I'm going to continue with this in about 10 minutes. I wrote some sort of script for break scripts. What's it called? Break. Start break. What does it do? We'll return when Pomodoro reaches 40 minutes, so I'll do Pomo start. And I'll be back in 10 minutes. And we're back from the break. Time to do another 15-minute POMO. Then I will have done 2-hour sessions, or a 2-hour session of studying today. And after that, I'm going to visit some family because it's Easter. So, POMO start. Another 15 minutes. Let's go.
Binaries. And we should extract these, which can take a little bit because in some they're actually quite large. And in that extracted folder, we can actually have a look in the server directory, bin directory, and there we see, for example, the API server binary, controller manager, etc. So we need to make sure to be able to compare this now that we have the proper version, right? So what we can actually do is we can simply run the kube API server binary, attach version, and we see I'm using version 1.22.2, and I'm using that version because in my cluster on my master node right now, that version is also running. How can we find this out? Well, in the kube system namespace, there should be a pod running for the API server. There we go. It's running as a static pod via kubeadm manifest. And if we have a look at what image it's running, then we actually see, okay, I'm also running right now version 1.22.2. So we can go ahead and compare the two binaries. First, we should probably get the hash of the downloaded binary from GitHub. For this, we can just simply run the SHA-512 sum. There we go. And what I do is I write it into a new file, compare. Now we need, for the comparison, we need to have the SHA-sum of the binary running inside the container, right? So what can we do? Well, we can try to exec into the container. And we try to get a shell. Doesn't seem to work. We try to get a bash, doesn't seem to work, okay? So these containers of the Kubernetes components can be considered hardened already because they don't even include a shell. They're probably kind of started from scratch and only the actual binaries pre-compiled from Golang are actually in that container and run. So it's like really minimalistic. So what can we do? Well, we know that the API server is running as a pod on our node on which we are right now. So we can have a look using creaseCTL. And there we see it's running here, which means we should also see the processes from that container.
Oh, yeah.
And there we go. There we actually see the kube API server process. And what we also see is the PID of the process. It might be a different PID for you, right? Using this PID, we can now actually access the file system through the proc directory. So what we can do is we have a look into proc, then the PID of our process, and then in the root directory, and there we see the root file system of the container. So what can we do? Let's search the whole root directory and look for the kube API server, and there we have it. So we can simply generate the SHA-sum for this one.
Good luck doing that on AKS.
And append it to our compare file. Now let's have a look in the compare file. Just from me looking at it, it looks like it's the same value. It's this
well done, sir.
Same hash, which is pretty good. But I can also go ahead and clean this up a little bit. Remove the, and if we compare the same as the Well, this was a pretty short, but for me, interesting section. We learned what hashes on the 12th container. This might be a bit outside of the scope of the CKS, but well, you never know what will be happen, right?
Okay, so it's outside of scope, but it's pretty fun. So I'm gonna do the scenario. Okay, validation successful. I'm gonna do the scenario, but I'm not gonna put more time into that. But it was pretty cool how he was checking out the or finding the container using the proc file system. Let me see. Was it hash? Is that the one that we need to do? Check the kubelet binary hash. I think that's the one. I actually should go. I think I cloned it, right? Yeah. CD killer sh CKS course. And scenarios MD. Cluster setup, secure ingress, CIS benchmark, verify platform binaries. That's it. Verify platform binaries kubelet. Yeah, that's the one. When the YouTuber you watch for DevOps content to learn watches another YouTuber for DevOps content to learn. Yeah. Well, that's how I learn, right? I have to gain the knowledge myself in order to transfer it to others. That's a fun comment. Thank you, Tom. Let's start. Compare the kubelet binary. Let's download that one. Not found. Okay. Oh, in the same version as the installed one. Okay, sure. So we have to first figure out what the version is. Well, we do that by kget pod and cube system and then kube API server control plane. Output that as YAML and then grep image. So 129.0. Well, man, set-o vi. So much better. 129.0. Downloading the binary. Then compare the SHA hashes and answer with this. Will take a while. So in the meantime, let's check out which kubelet. And I'll have to get the SHA 512 sum of user bin kubelet. Okay. Sum. Here it is. Oh, that's taking a long time to load. Okay. But I think that should be it. Because the kubelet is actually a binary running on the thing. But it was pretty cool how it was figuring out. Let's see if I can do the same about the kube-API server. So was it PS? Like, well, he was using creectl, right? creectl PS grep API. So this is the API server. So PS aux grep API. Yeah, here is the process running kube-API server. So if I go to cd proc, here is the, that's pretty cool. Here is the root file system of that container. And then it was, okay, yeah, sure, I have the root file system, but what is the binary then? cd root. Yeah, here's the thing, cd var lib. Oh. How did he get the binary then? Where was the binary in the container file system? Because I have the, I'm in the file system, but how did he get the binary from there?
Process, and then in the root directory, and there we see the root file system of the container. So what can we do? Let's search the whole root directory and look.
Yeah, okay. So I'm in root and then find dot grep API. Here, user local bin kube API server. There's the binary. Cool. Has this one downloaded yet? Still not. 10% left. This is a long scenario. What is the next scenario gonna be? Cluster hardening RBAC. Ah, okay. Yeah. So I'm familiar with RBAC, but I've heard that the exam actually has a lot of questions on network policies and RBAC. So what I'm doing now is I'm practicing network policies every day. I really want to get it in my fingers, in my memory, that I don't have to think about those on the exam. And from what I've heard, like I've spoken to a few people who have recently taken the exam, that like maybe half of the points you can score by knowing network policies and RBAC well. So those are easy points, right? It's not hard. You just have to, like, it's hard if you haven't done it for a few weeks. You know the mechanics, but you have to sort of look it up and really think through it. But that's what I'm going to be practicing every day, so that I have those sort of in the muscle memory and readily available in my mind, and then I can quickly score points. So I'm happy that I'm finally getting to the RBAC module, because then I can start practicing that every day too. So our binary is finally here. So I have the binary, and it is actually a zipped one. So I'll have to unzip it, I suppose. Ooh, how do I do that again? He did that too, right? He unzip tar gz tar xvcf. Oh, it's downloading the entire Kubernetes kube-ADM binaries. Aha. Okay. So Kubernetes, and then in here there should be the kubelet. So find dot grep kubelet cd server bin. So kubelet is here. Kubelet. Then it is SHA-52 sum kubelet. That is this one. And now I'm going to do that, redirect that to my, what did I call it? Sum MD. And then vim sum MD. Oh, oops. I should have appended that and not. PS aux grep. No, it's just which kubelet. And then SHA-52 sum user bin kubelet. And redirect that to sum MD. Okay, so here is the file, and they are actually different. They are actually different. So then I can do echo different to answer, and then this should be the right answer. Validation successful, yay. So let's check if how they do it. Download. Oh, interesting. I actually got the version from the API server, but he is doing it from the kubelet. So echo version. Yeah, that's also 129.0. 129.0. So that I got the right version. To our XPCF, yeah. Yeah, basically the same. And I got the right solution. Okay, cool. That was fun. So let's move on to the next one. Role-based access control. It is boring and annoying, but very important to know. And it's going to be scoring me a lot of points on the exam. So let's get to it.
Role-based access control, very important, very big topic. I hope you're ready. I'm definitely ready. We will first talk about role-based access control, and I will explain it to you simply and visually. Afterwards, we will create a few scenarios, and we also work with certificates and users. Role-based access control is a general concept of regulating access to computer or network resources based on the roles of individual users within your organization. Kubernetes has it as well since early versions, and it's enabled via the authorization mode string. It's default always allow, but there's also the role-based access control, which is if you have a kube-ADM cluster, it's enabled by default. So we can use it to restrict access to resources when accessed by users or service accounts, and we will talk about users and service accounts later as well. We always work with roles and role bindings, and you always specify what is allowed and everything else is denied. So you whitelist what is allowed. There's no deny rules in role-based access control in Kubernetes. Only access data or information.
That's an important note. So I'm going to open my Kubernetes node. And let's create a new one called RBAC. And the node I want to create is there are no default denies in Kubernetes RBAC. So how did he phrase that?
We always work with roles and role bindings, and you always specify what is allowed and everything else is denied. So you whitelist what is allowed. There's no deny rules in role-based.
Oh, okay, I got that wrong. There are no deny rules in RBAC. You only everything is denied. Yep. There are no deny rules in Kubernetes RBAC. There are no deny rules in Kubernetes RBAC.
With access control in Kubernetes. No deny and everything else is denied. So you whitelist what is allowed. There's no deny rules in role-based access control in Kubernetes.
Yeah, so to put it in my own words, it is only possible to allow permissions in Kubernetes you can only whitelist. It's a bit different from how he said it, but that's what I'm doing, right? I'm doing the Zettelkasten method. So I'm just making a small atomic node, and this is all I want to note for that. So I'll move that to the ZP directory. And going back to my RBAC, this is also a node that I want to publish. And now in 20 minutes, this is going to be published on my public Zettelkasten. You can check that out here. This is my website. I have a blog, but I also have a public Zettelkasten. And here you can see that, like here, this morning I added a note about adding container images to Rancher Desktop and pulling them. And here is the Kubernetes map of content. So there will be a new thing appearing here about RBAC in about 30 minutes. Then it will publish it automatically. So you can follow along with my studies in my Zettelkasten, and I'm publishing all of the notes here as I go along.
Only access data or information that is necessary for the legitimate purpose. So it's kind of the principle of least privilege, which should always be in the back of our minds when we define role-based access control rules.
Yeah, that's always in cloud engineering, infrastructure engineering, it's always the principle of least privilege.
And let's talk about namespace and non-namespace resources before we jump into the role-based access control resources. So Kubernetes has namespaced and non-namespaced resources. We can actually look at them if we run kubectl API resources and then the namespace parameter true or false. Namespace resources are, for example, pods. Non-namespace resources are, for example, nodes or persistent volumes.
Yeah.
And yeah, if we look at role-based access control, then there we also have the namespaced role and the non-namespaced cluster role. Okay. Yeah. And the role and the cluster role, they define a set of permissions, and a set of permissions can edit pods, can read secrets. Okay.
Yeah, I remember this from the CKS exam.
So we define a set of permissions. Then we have role binding and cluster role binding. And with these bindings, we define who gets a set of permissions, like bind a role or cluster role to something or someone.
Yeah, and it's always bound to service accounts.
So when we look at roles, to describe them, we could ask the questions, where are the permissions available? Okay. So we define a set of permissions and we say where it is available. Like when we define a role, then we define a set of permissions which is available in one namespace. If we define a cluster role, then we define a set of permissions which is available in all namespaces and also globally in the cluster. Okay. When we go to the right side with the bindings, then we can ask the questions, where is a set of permissions applied? Because if we use a role binding, then it's applied in one namespace. If we use a cluster role binding, then it's applied in all namespaces. Using these 4 resources, there are various combinations of these, and we will get into the valid combinations just in a few slides ahead. Let's have a look at a role, like an example role. We call it Secret Manager, and it is in namespace blue, right? Under rules, we have resources, so this is about secrets, and we are allowed to get, watch, and list secrets. Now we create a second role, which is very similar. It's also called Secret Manager, but it's available in namespace red. Okay, we have one in namespace blue, one in namespace red, and the one in namespace red allows less. It only allows us to get secrets, whereas the other one allows us to get, watch, and list secrets. So using this, we have the same role. We have the same role with the same name, Secret Manager, in 2 namespaces. But in every namespace, it has different permissions. It allows us to have different actions, right? So a user...
Yeah, it's an entirely different resource. And because they're in the different namespaces, then they can also have the same name.
Can be Secret Manager in multiple namespaces, but the permissions are different in each namespace. Now let's look at the example when using a cluster role. Now we have a cluster role, Secret Manager, instead of a role as before, and it allows us to get secrets. As you see, there's no namespace in a cluster role because it's a non-namespace resource. And this would allow us then, a user can be Secret Manager in multiple namespaces, but the permissions are the same in every namespace. Okay? This just as like two example usages between a role and a cluster role. If we look at a cluster role, then we have to be careful, right? We should be careful with cluster roles and cluster role bindings because they apply to all current and future namespace and non-namespace resources. If you have 3 namespaces and you say, yes, my user should have access to all these 3 namespaces, then you can create a cluster role and a cluster role binding. But you should be aware that as soon as you add a new namespace in the future, the user having that cluster role and cluster role binding will automatically get access to that namespace created in the future. So be careful with cluster roles. We now look at combinations, okay? We again have our 4 resources for role-based access control. We have a role, we have a cluster role, we have a role binding, we have a cluster role binding. How can we combine these, okay? We remember a role defines a set of permissions. That set of permissions is applied in a single namespace, okay? This works. Another combination available in all. The user has that set of permissions in all permissions is applied in all namespaces. Set of permissions in one or in a few namespaces, right? Because the set of permission is available in all namespaces, but we just apply it maybe in 1 namespace or in 2 namespaces by creating a role binding in all these namespaces.
Oh, that's interesting. So you can have a cluster role which is available in all namespaces, but if you only create a role binding in a namespace, it has the same permissions in multiple namespaces.
Well, is
that true?
All namespaces. Set of permissions is available in all namespaces. Set of permissions is applied in all namespaces. Another combination is we still have a cluster role, set of permissions available in all namespaces. We now apply it just in 1 or in a few namespaces, right? Because the set of permission is available in all namespaces, but we just apply it maybe in one namespace or in two namespaces by creating a role binding in all these namespaces.
Yeah, okay, so that was confusing me. So when you create a role binding in one namespace, then it will only apply these permissions in that namespace. But you can do it in multiple ones. That's what he's saying here. So this comment here confused me. But you can have a cluster role that is available in all namespaces, so you get all of the permissions. And if you have a cluster role binding, then it's available to all namespaces. But if you assign the role binding only to that namespace, even though it is a cluster role, it will only apply to that namespace. So I'm gonna write a note on that, I think. Cluster roles can be applied to single namespaces. Cluster role is available to the entire cluster, but you will only receive these permissions in all namespaces if a cluster role binding is created. You can also create a normal role binding, which is a namespace resource. Then the permissions will only apply to that namespace, even though it is a cluster role. You can also have role bindings from multiple namespaces, and the cluster role will only apply to those namespaces. Yeah. Can be applied to one or more namespaces. Let's clean it up a bit. Cluster role. If a cluster role binding is created. Yeah. Publish that.
Well, is there another combination? Can we create or combine a role with a cluster role binding? No, we can't do this. Why? Well, because a role defines a set of permissions which is only available in one namespace. And if it's only available in one namespace, then we can't apply it to all namespaces using a cluster role binding. Yep. So these are the three combinations which are possible. Permissions are additive, which means we always specify what is allowed, everything else is denied, so we whitelist. And permissions are additive, which means, let's have a look at a simple example, okay? Yeah. Let's say we have a cluster role in a cluster role binding, which allows us to get and delete secrets. Then we define, for the same user, we define a role and a role binding in a certain namespace, which only allows to get secrets. Okay? The result will be that the user is able to get and delete secrets in that namespace. So even if for one namespace here, we define stricter role bindings or stricter rules, role-based access control rules, it doesn't restrict them, right? Because as soon as the user has to get and delete secrets, as soon as he is allowed to do this, you can't create more restrictive roles afterwards. Always test your robust access control rules. Just a reminder, never trust your skills just like that. Always verify. We will do this in the hands-on.
Let's create a short note on that as well. RBAC permissions are additive. Permissions from cluster role bindings and role bindings will be added.
Sessions. And with that, I would say
Added to each other.
let's move on. We will now create a first simple scenario. We will create two namespaces, red and blue. And we have a user Jane, and that user Jane should be secret manager in namespace red and blue, but it will have different permissions in each. So user Jane can only get secrets in namespace red, and user Jane can only get and list secrets in namespace blue. And we will test it.
Okay, so I'm gonna do this in my Rancher desktop cluster. Okay, create ns red. Okay, create ns blue.
Using auth can I. Okay, we should be on our master node cluster ready as always. First, we will create the namespaces red and the namespace blue. There we go. Now, user Jane can only get secrets in namespace red. Okay, for this we will create a role and a role binding. Okay, whenever you have to create a role and a role binding, cluster role binding in the CKS, you should be comfortable just using kubectl. Don't go copy a role from some YAML place from the docs and then try to edit it, right?
Just generate it.
It's way faster like this. So in namespace red, Jane can only get secrets. So we create a row. We name it secret manager. And we specify the verb, only get, and the resource is secrets. I will print out the YAML now, just for us to see. And there we see, we will create a role. It called secret manager in namespace red, and the resources secrets and verbs get. Great, let's create it. And now we will create a role binding to the user Jane. So role binding is namespaced in the same namespace red. We create a role binding. We call it as well secret manager. We specify the role. The role is secret manager, and then we specify the user. The user is Jane. Again, for now, I will do a dry run for us to inspect this. We create a role binding. It will bind the role secret manager to the user Jane. That's what we want, exactly this. Okay. What else do we want to do before we start to test and to verify our skills? User Jane can only get and list secrets in namespace blue. Okay, so kind of the same thing for namespace blue. What we do at first, we create a role. But in namespace blue, create role, we call it secret manager as well.
Oops, I messed up here. Okay, get role bindings. Okay, delete role binding secret manager, because I made a typo. Here we go. Should be here then.
Verb is get, and we write another verb list because we say get and list secrets in namespace blue.
So then it is KM blue, create role, secret manager, get and list. KM blue, create role, secret manager, verb is get, list, resource is secrets. Oh, YAML dry run is client.
There we go. And then we as well create a role binding, also called secret manager, in
KN blue, create role binding. Role is secret manager. User is Jane. Create role binding secret manager. Okay, here we go.
namespace blue. And that should be it. The comments, by the way, you should be very comfortable with typing these and fast, but they're also in the resources section of this video.
Yep.
Okay,
so that's what I'm going to be training on.
So there is K, kubectl auth can I. Okay, and as always, the help page already shows many useful examples. We now want to test in namespace red. Can I get secrets as user Jane?
Let's see.
Auth can I? Yes.
K. Oh, I remember this. K red auth. Can I get secrets as Jane? Yes. And then in blue. No. Yeah.
Yes, I can do it. Can I do it as user Tom? No. Can I delete secrets as user Jane in namespace red? No. Can I list secrets as user Jane in namespace red? No. But I should be able to list secrets in namespace blue as user Jane, and I should be able to get secrets user Jane, right? And
let's see. Can I list secrets as Jane in namespace blue? Oh, no role secret manager found. Okay, create role. Forgot to create the role.
What about other things? Can I get pods as user Jane? No, right? Because we defined that one set of permissions that the user is only able to do, and
user can only get and list secrets in namespace blue. So then it should be kn blue create role secret manager. Verb is get list. Resource is secret. Okay. And then now kn blue auth can I
everything else. That can I get pods as user Jane? No, right?
get pod as Jane? No. Can I list secrets? Yes. Okay, now it works.
Because we defined that one set of permissions that the user is only able to do, and everything else is denied. We will now create another scenario or extend the existing scenario by creating a cluster role, one cluster role binding and one role binding. And we introduce Jim to the game. What will we do? Well, we will create one cluster role, deploy deleter, which allows to delete deployments. Then we create, or we allow Jane to delete deployments in all namespaces. So we create a cluster role binding. Then for user Jim, we allow to only delete deployments in namespace red. So we will create a role binding, and we will test everything using auth can I as before. First thing, let's create a cluster role deploy deleter, which allows to delete deployments. Create cluster role -h, always helpful, right? We see various examples, but it's the same thing as if we create a role as we did before. So we specify a verb, which means delete, and a resource, which will be deployments. And we have to give the cluster role a name. So we call it deploy deleter, right? That's what we want to call it. Deploy deleter, correct. There we go. It's created. Let's move on. User Jane can delete deployments in all namespaces. So we now, for user Jane, create a cluster role binding for that cluster role.
Okay, create cluster role binding.
Okay, create cluster role binding. We call it deploy deleter. It is for user Jane. And we specify the cluster role deploy deleter. There we go.
You have to write cluster role, not role.
Next, user Jim can delete deployments only in namespace red.
Create cluster role binding. Cluster delete. And then if I go kauth, can I delete deployment in the namespace Zettelkasten or namespace Mealy as Jane? What was it?
So we will create a role binding in namespace red for that cluster role. Okay, in namespace red, create a role binding. We call it deploy deleter for user Jim, and for cluster role deploy deleter. There we go. Okay, let's test what we did here. Okay, let's test for user Jane in namespace default, or let's
just create the one for kn red, create role binding. Binding deploy deleter, users, gym, cluster, role, deploy deleter.
Let's first do without any namespaces. Kauth, can I delete deployments as Jane? Yes, I can.
Yep.
Can I do it in all namespaces? Yes, I can. Can I do it in the default namespace? Yes. Can I do it in the red namespace? Yes. Can I delete pods? No. Right? It's great. Jane can delete deployments in all namespaces. How does it look for user Jim? Can user Jim delete deployments in the default namespace? No. Can user Jim delete deployments in all namespaces? No. Can user Jim delete namespaces, delete deployments in namespace red? Yes.
No.
There we go. Okay. You should get familiar with these. Maybe look also at the YAML that's generated by the comments, but usually if you have to create roles, role bindings, cluster roles, cluster role bindings, it's very easy to do this using kubectl and then to test it using kubectl as well. And the comments that we used in this section are also in the resources of this video. Have to create roles, role bindings.
So that's the end of this Pomodoro. It is now 10:30 and I'm debating whether I should continue or not. I'm going to family after this and I need to do a few chores before I leave. So it feels a bit dumb to end it in the middle of the RBAC module though. Yeah, I think I have another Pomodoro in me. I think I'm gonna not do the entire one, but I do want to finish this module and I'll have to just do my chores this evening. So I'm gonna take a break and then I'll continue with another partial Pomodoro. I'll be right back. And we're back. Gonna keep going for about half an hour or so. And then I'll go and have brunch with the family.
Cluster roles, cluster role bindings, it's very easy to do this using kubectl and then to test it using kubectl as well. And the comments that we used in this section are also in the resources of this video. We will now talk about accounts in Kubernetes. So accounts in Kubernetes, there are service accounts and quote normal users. Service accounts are used usually by machines like pods to access the Kubernetes API, and service accounts are actually managed by Kubernetes API, which means there is a service account resource in Kubernetes that can be created, edited, deleted. For normal users, this is not the case. There is no Kubernetes user resource. A user is simply someone who holds a certificate. And this is done so that outside services can easily integrate with the Kubernetes identity management. So the identity management of cloud providers like AWS or Google Cloud simply have to issue certificates and to store and manage certificates and keys, and can then use these to communicate with the Kubernetes API. So what is a normal user in Kubernetes? There is no Kubernetes user resource. A user is someone with a certificate and key. So if we have a user certificate, a client certificate, then it has to be signed by the certificate authority of the Kubernetes cluster. And we will see how it's done in the next slide. And in that client certificate, there will be the CN, the common name entry. And if it's set to Jane, then the username is Jane. And if you then send a request to the Kubernetes API containing that certificate, then you will register, you will be able to execute commands under the user Jane and under the permissions that the user Jane has. How can we get a certificate signed from Kubernetes? Okay, so the procedure would be, first we will have to have a certificate.
So that's really interesting. I was thinking about it while I was having my break. Like, we were assigning it to users, but how are the users actually defined? So I'm gonna write a couple of notes here. Service account. Service accounts are only used by what do you call it? By non-humans. Used for in-cluster controllers, etc. How did he explain that?
Actually managed by Kubernetes. Quote, have to create to do this in the resource. We will now talk about accounts and quote normal users. Service accounts are used usually by machines like pods to access the Kubernetes API, and service accounts are actually managed by Kubernetes API, which means there is a service account resource in Kubernetes that can be created, edited, deleted.
Yeah. For in-cluster controllers, pods, managed by the Kubernetes API and lives in the cluster as a resource. So if I go to get service accounts in all namespaces, I see a bunch of service accounts. And if I do get service account nkube system, and let's take the Helm traffic one and output that as YAML. Here I can see the service account here with token. Yeah. Interesting. There are also get service account. I'm also seeing here that every namespace gets a default service account. Get service account. Namespace melee default. and output that as YAML. Because each namespace by default gets a service account. I didn't know that. That's interesting. Makes sense though, because then everything in that namespace can be authorized to do certain things. That's really cool. But so the service account are only used by non-humans, used for in-cluster controllers, pods, managed by the Kubernetes API, and lives in the cluster as a resource. So that's ready for publication. And then users do not live in the cluster as resources. That's really important. There is no user resource in Kubernetes.
For normal users, this is not the case. There is no Kubernetes user resource. A user is simply someone who holds a certificate. And this is done.
Users are authorized by TLS certificates.
So that outside services can easily integrate with the Kubernetes identity management. So the identity management of cloud providers like AWS or Google Cloud simply have to issue certificates and to store and manage certificates and keys, and can then use these to communicate with the Kubernetes API.
So how that works in AKS is that you have Entra ID, and those are users, and then they can be authorized to get the credentials, and when they do, then it is actually linked to your Entra ID, your user ID.
So what is a normal user in Kubernetes? There is no Kubernetes user resource. A user is someone with a certificate and key. So if we have a user certificate, a client certificate.
Okay. Move that. And just for fun, let's see if the other new nodes were already published. Refresh. Yeah, here. So here on my website, zettelkasten.mishavandenberg.net, you can see that the nodes that I was adding just now, like RBAC permissions are additive. These are all now available on my Zettelkasten. So every time I move them to the ZP directory in Obsidian, a cron job handles it and it will be published. So you can actually see all of the nodes that I am creating during this stream at zettelkasten.mishavandenberg.net. I'm pretty satisfied with this. I set this up a couple of days ago. It's pretty cool. So authorized by TLS certificate, Kubernetes users are authorized. No, do I say that right? No. Are simply holders of TLS certificates. The cloud provider will handle issuing these certificates when the credentials kubeconfig is retrieved.
Certificate, then it has to be signed by the certificate authority of the Kubernetes cluster. And we will see how it's done in the next slide. And in that client certificate, there will be the CN, the common name entry. And if it's set to Jane, then the username is Jane. And if you then send a request to the Kubernetes API containing that certificate, then you will register, you will be able to execute commands under the user Jane. And
So I'm gonna copy this slide and add it into my notes here. That's really interesting. So the client certificate will be signed by the cluster CA, and the CN is the username.
Under the permissions that the user Jane has. How can we get a certificate signed from Kubernetes? Okay, so the procedure would be, first we will have to have a certificate signing request. We simply create it with OpenSSL, and we will do it soon in a hands-on session. So we create a certificate signing request. Then we can include the certificate signing request in a Kubernetes resource, which is called certificate signing request. We send it to Kubernetes. Kubernetes then uses the certificate authority, which it already has access to, like the Kubernetes API server has access to the certificate authority. The API Kubernetes uses this then to sign the certificate, updates the certificate signing request resource, which then includes the certificate. And then we as a user can download it, or we as an administrator can download it and distribute it to our users. Why like this? It's not even necessary to have the API in the middle, right? If you have a certificate signing request, all you have to have is the certificate authority file, and then you can create the certificate. But it can be difficult to manage and to distribute the certificate authority. Like when you want to sign a certificate, you may have to download the certificate authority from a server and then use it and delete it afterwards. So this is why Kubernetes introduced the certificate signing request resource and process to make this more secure and more easy. Okay, just a minute, something about leaks and invalidation. So there is no way to invalidate a certificate. Once a certificate is issued, it is valid as long as the expiry date. Okay, so what happens if a certificate has been leaked? Like a user reports, my certificate has been stolen by someone. What can you do? Well, what you can do is you could remove all access via robust access control so that the user doesn't have any more permissions in the cluster. The username cannot be used anymore until the certificate is expired. Or you have to create a new certificate authority for your cluster and reissue all certificates, okay? So it's not the best procedure, and it's not an easy procedure what has to happen if there has been a leak. We will now authenticate as a normal user, Jane, with the cluster. For this, we will create a certificate and key and authenticate as user Jane. We will create a certificate signing request. We will sign it using the Kubernetes API, and then we will use it using the kubeconfig to connect to the Kubernetes API. So the steps will be the following. First, we will create a key using OpenSSL. Same, we will create a certificate signing request. Then we will send this one to the API. The API server will sign it for us. Afterwards, we download the signed certificate from the API, and then we use it to communicate with the Kubernetes API. So try to follow along. It's important to understand this. The comments that we used here are also in the resources section. Okay.
I wonder if this is actually part of the exam. I don't think so, because I don't think you have to know OpenSSL for the exam. But it's still really interesting, but just a thought there.
What do we have to do? Well, first we have to generate a key. So OpenSSL generate, you don't have to know these OpenSSL comments by heart, and or you can also copy the OpenSSL comments from the resources section, but just...
Oh, well, there it is, that confirmed. He says you don't have to know them by heart.
Be comfortable with these. So now we created a key. And now from that key, we can create a certificate signing request, jane.csr. And in that certificate signing request, we can leave everything empty. But when we come to the common name, to the CN, then as we learned, this will be the username that we use to authenticate with Kubernetes. So it has to be Jane. There we go. We have a certificate signing request and we have a key. Now we would like to create a Kubernetes resource which is called certificate signing request. So head to the Kubernetes documentation and search for it. Certificate signing request. Scroll down, it should be a bit down till we see an example. At first they talk about, there we go. Here we see one. They execute it in one comment, but we can simply copy the YAML out of it. I create a new file, csr.yaml, paste it in. Okay. We change the name to Jane. And then the whole request, I will delete it because in the request field where I now have written to do, there we have to paste the actual certificate signing request file, base64 encoded. Okay. So I'm not creating the resource right now. What I now need to have is the jane.csr base64 encoded. Okay. And what I can actually do to get this, and the comment is also in the resources, we can do.
I'm not following all along with the practical thing here because I don't want to mess up my kubeconfig file with another user, and I don't think you actually need to know this for the exam, but it's interesting to watch.
64, but then
I understand fully what's going on here, so I'm not concerned.
We still have the new lines, right? So we can do -w0, and there we go. Copy it, edit the resource again, paste it in the request section, and that's it. Now we will create the resource, the certificate signing request resource. It worked. And we can get CSRs, and there we see there's our Jane CSR, and the condition is pending. So now the idea is that the administrator can approve that certificate signing request. Okay, it's not automated just like this. It's still secure in that sense. So what we can do is certificate, let me have a look, approve. You can also have the help sections. There's approve and deny, but we want to approve it, and we want to approve certificate Jane. And if we look at the certificate signing request again, then we see now the condition is approved, issued.
Interesting. I've been working with CSRs and stuff for my ingresses, but then I use Cert Manager, and then those are approved by Cert Manager. So it's interesting to see this process manually.
We get the certificate signing request from Jane as YAML. Then we see now in the status section, we have actually the certificate. That's our certificate that we can use. So copy it. It's in base64, so we base64 decode it. There we go. Looks great. We paste it into a file called jane.cscrt for certificate. And that was much of the procedure already. So where are we? We created a key. We created a certificate signing request. We sent it to the API. The API approved it for us. We downloaded the certificate from the API. What we now have to do is to actually use the certificate and the key to connect to the Kubernetes API. How can we do this? Well, if we have a look in our kubeconfig, we can actually do kconfig view. This is our kubeconfig file. Right now we have one.
I knew this was going to come. That's why I don't want to do it, because my kubeconfig file is full of things for work as well. So
cluster. We have one context which connects a cluster with a user, with the admin user, and we only have one user down here, the admin user. So what we can do is we can create another user for Jane and another context for Jane, which connects the user Jane with the cluster. What we can do to do this is kconfig set credentials, and we call the credentials Jane. And then you specify the client key, and it's jane.key. and you specify the client certificate, which is jane.crt. Okay. User Jane set. If we have a look at kconfig view, then we actually see nice. We now have a user Jane down here as well with a client certificate and client key. These are referenced to the files. Okay. Down here you see that we actually have client certificate data entries, which are redacted right now for security reasons. If we want to actually include the values into our kubeconfig, we can simply run the same command again, set credentials, with embed certificates. There we go. Let's have a look at kconfig view. The user was overwritten and we see now it's actually included in our kubeconfig file. If we want to see the raw values, then we can do kconfig view -- raw. Right?
Yeah,
but this is enough for us right now. Now we need to have a context because we want to connect the user to the existing Kubernetes cluster. So same
switch to
thing or
context.
similar thing, we can do kconfig, set context, we call it Jane, and we want to connect user Jane with cluster Kubernetes. Done. If we now do kconfig get contacts, then we see we have a context, right now the admin context and the Jane context. So we do kconfig use context Jane, and now we are user Jane. Get namespaces, I'm not allowed to get namespaces. Why? Because by role-based access control, we didn't give Jane any permissions to get namespaces. Do you remember what permissions Jane had? Well, Jane should have permissions in namespace blue to list secrets. So let's have a look if we can get secrets. There we go. We can get secrets.
Very nice.
We can also, can we delete secrets? Let's try to delete that secret. No, we have no permissions to do this. So, and here in the response, we actually see user Jane cannot delete resources. We can now also do kauth can I delete deployments. There was like the deployment deleter. Can I delete deployments in all namespaces? Yes, because we gave through a cluster role and cluster role binding, we gave user Jane that permission. And then can user Jane delete pods in all namespaces? No. Okay. So we are now authenticated as user Jane with the Kubernetes cluster, and we did that whole scenario, which should make it clear. I suggest if you want to get a bit more familiar with it, simply do the same thing with user Jim. Okay, just the same thing that we now did with Jane, go through all these steps, do it again with user Jim, and then you should have another entry for Jane and for Jim and for the Kubernetes admin in your kubeconfig, and you can switch between the contexts and test out the permissions. We reached the end of the role-based access control section. It was a big section. It is an important topic. If you like to go a bit further, then I suggest to really read through the reusing role-based access control documentation page. We will also face role-based access control throughout other hands-on sessions and other topics, because it's just a topic which is prevalent almost everywhere when it comes to security. What did we talk about? Well, we talked about roles and cluster roles, role bindings as applying API.
Okay, so there are a few killer code scenarios here, but I'm just going to find out if that is part of the CKS exam, if this creating users and authenticating with certificates, if that is actually something that I will need to know. Use RBAC to minimize exposure. Service accounts, updating. Properly set up ingress user, ingress objects. Minimize YAM rules, okay. I actually don't think that is necessary here. Yeah. I'm fairly certain I don't have to actually know that. But like, it's not that I don't want to learn, but it's just for me to verify whether I actually need to know this. So let's see the check out the resources here. Scenarios. Hardening RBAC. There are a few here that need to be run. What is wrong with my Vim though? Like something is, because I've been switching windows so much, something is a bit weird. Scenarios. Maybe I should just do it CKS course environment. It is rendered as a table, so that's a bit nicer. Scenarios. Here. RBAC service account permissions. I have about 15 minutes left, so I think I'm just going to do 1 or 2 scenarios and then I'll have to call it a day. Actually, I can only do 1 and then I'll have to get ready for the Easter brunch. Let's see, there are existing namespaces, namespace 1 and 2. Create service account pipeline in both namespaces. These service accounts should be allowed to view almost everything in the whole cluster. Okay, so let's see. K create service account pipeline and ns1, ns2. View almost everything in the whole cluster. So K create cluster role binding and ns1 cluster role view, and then is it user or service account? Okay, create cluster role binding by plus cluster role user. Service account is namespace service account name. That's the usage. Okay. So I'm gonna open tmux. And here I'm gonna do that again. So K create cluster role binding. Pipe it to less. Service. Here. Okay, create cluster role binding cluster viewer, and then cluster role is view, then service account is ns1 pipeline. Okay, and then also for ns2 set-ovi cluster viewer 2. So that is created. So let's verify kauth can I grep service So k auth, can I list pods as system service account cluster viewer 1, the cluster viewer of namespace 1 in n-2. You cannot list pods. Can he view? Oh, view is not a known verb. He should know it, right? He should be able to list it. What is the verb for view? Okay, get cluster role view. Oh, YAML. Get list watch. Okay. So why is he not allowed to do that then? Can I view pods as service account cluster viewer living in the namespace 1? So k ns1 get service So there's default pipeline in service account cluster viewer. So then k create cluster role binding cluster viewer 1. Cluster role is view. Service account is ns1 pipeline. Okay, get cluster role bindings cluster ns1 cluster viewer 1. So k auth, can I get pods k auth, can I list pods as system service account ns1 pipeline it's not working. Okay. Well, actually, I have to leave now. I have to get ready. So I think I'll have to cut it off short here. I'm sorry about that, but this is why I'm going to be practicing these scenarios every single day, because this stuff needs to be in the fingers. You need to be able to read this and just do it instantly. And this is one of my weak points: network policies and role-based access control. So I need to do a lot more practice, but that's what it's all about, right? So yeah, thanks for tuning in. I have to go to my Easter brunch now. So maybe I'll do another stream later this week, and I'll see you in the next one. Have a good